The first step to be able to get the ratio, we must derive the original function. Since this is a fraction, we must apply the quotient rule, which consists on dividing the numerator or classifying it as f, function f, and the denominator as function g. So we're gonna write it like how it is: 10,000 function g, 10,000 function f, 10,000, and then we're gonna write its prime. So f prime will be 0 because 0 is a prime of 10,000. Then we get g, which is 1 plus 19e to the negative t over 5 power. We write it here, and then we write its prime, which its prime is 19 over negative 5, that is a negative number, to the e to the negative t over 5 power. So now the quotient rule consists on multiplying g times f prime, which we get 0, because any number multiplied by 0 gives 0, minus, which is part of the quotient rule formula, f times g prime. So we're going to multiply 10,000 times negative 19 over 5 e to the negative t over 5 power. And all this, we're going to put it over g squared because it's part of the quotient rule formula.
To continue, we need to multiply negative 10,000 with negative 19 over 5e to the negative t over 5, which means it will be positive 190,000 e to a negative t over 5, and the 5 that it's in here will be dividing all these equations. And we just copied the same equation that we had in here. To finish the equation, we just need to divide 190,000 over 5, that will be 38,000 e to the negative t over 5 power, divided by 1 plus 19e to the negative t over 5 power, everything squared.
Now we're going to substitute in the equation to find the ratios of 1 and 10 months. For 1 month, we'll have 38,000 e to the negative 1/5 power over 1 plus 19e to the negative 1/5 power, all of it squared, and we're going to get 113.51 for the 1 month ratio. And for the 10 month ratio, we're going to substitute the same as we did with number 1, but only with 10, to get 38,000 e to the negative 2 over 1 plus 19 e to the negative 2, everything squared, and we'll get 403.204 for the 10 month ratio.
After graphing the original function previously shown, we got this beautiful graph. So if we zoom it in, we can see here is the x-axis. So we can see that when x approaches the positive infinite, that which is this side, the population growth has a limitation in 10,000. So we can conclude that when the fish gets into 10,000, the population, it doesn't have any growth.